Hello friends, welcome to the class. So after learning all the concepts in gravitation, let's go and practice some questions based upon the concept of gravitation, and the pattern will be JEE Advanced. In JEE Advanced, we have questions that are single choice, more than one choice correct, integer type, assertion region, and even matrix match. Today's class will be having single choice, then again more than one option correct, and integer type pattern, and then again assertion region. Let's go ahead and let's not waste time. Let's go ahead with the first question of the class. The first question, mass density of a solid sphere is rho. Solid sphere, its mass density is given as rho. Radius of the sphere is capital R. The gravitational field at a distance r from the center of the sphere inside it is. So based upon its mass density, we have to give the gravitational field at the center at a distance r from the center. Option number A, 4 rho g pi r by 3. B, 4 rho gr square by 3. C, 4 rho gr cube by 3r square. D, rho gr cube by pi r. Now, if you remember, we have done for gravitational field at any point inside the sphere, we have done its gm by r cube multiplied with r. We need to actually relate how it is related with rho. So what you can write for mass? You can write mass as density into volume. So density is rho into its volume 4 by 3 pi r cube divided by r cube multiplied with r. From here you see what you will be obtaining. You will be obtaining 4 by 3 g rho pi r. This r cube will be cancelled out. So 4 by 3 g rho pi r. Let's check with the answer. We have 4 by 3 rho g pi r, 4 by 3 rho g pi r. So option number A is the right answer for this question. I hope that you have understood how to solve such kind of question. If you know the formula, you can easily go ahead and you can solve such question. Next question of the class. Let's proceed. Second one, a satellite is moving with a constant speed v in a circular orbit about the earth. So satellite motion we have to study. An object of mass m is ejected from the satellite such that it just escapes from the gravitational pull of the earth. At the time of its ejection, the kinetic energy of the object is A, half mv square, B, mv square, C, 3 by 2 mv square, D, 2 mv square. What generally student will do, he will try to actually write on the formula for escape velocity related with the speed of the satellite. But in this case, I will try to give you an easy and short trick to actually do such kind of question. You see it is given that the satellite is moving with speed v. Satellite is moving with constant speed v. That means the kinetic energy of the object within the satellite will be given as, kinetic energy will be half mv square. That's quite obvious. We all know potential energy is minus of twice of kinetic energy, that I have told you in the class also. Do this, minus of twice kinetic energy is half mv square. So you'll be obtaining this as minus mv square. We obtained this. This is the value of potential energy. Now see here, an object of mass m is ejected from the satellite such that it just escapes from the gravitational pull of the earth. At the time of its ejection, the kinetic energy of the object is. So you have to provide that much kinetic energy that will overcome the net negative potential energy. You see here the potential energy is this much. If you provide this much energy, that means if this much energy you provide, you will be able to let the object within the satellite to escape. So energy that will be provided, that will be equal to mv square. Provide this much, you will be overcoming the potential energy which is actually trying to stabilize the object within the satellite. This is how you have to do the shortcut, and mv square will be the answer. Option number B clearly matches with our response. So B is the right answer for this question. Next question, I believe that you would have understood how to solve such kind of interesting question. Next question of the class, we have third one. A satellite S is moving in an elliptical orbit. Let me just rub this part around the earth. The mass of satellite is very small compared to the mass of the earth. Satellite is moving all around the earth, that means planetary motion we are talking about. A, the acceleration of S is always directed toward the center of earth. First of all, before reading all the options, let me show you the motion. Satellite motion, and let's say this is Earth. And let's say the satellite, it is moving. The satellite is moving in an elliptical orbit. I made an elliptical orbit. I showed you the Earth. The acceleration of S is always directed towards the center of Earth. Yes, it is always directed towards the center of Earth. That will be always towards the center of the Earth. This will be the direction of acceleration. Next thing, because centripetal acceleration will be only acting. Next thing, the angular momentum of S about the center of Earth changes in direction, but its magnitude remains constant. Already we got the right answer, but I will be talking about all the options. The angular momentum of S about the center of Earth changes in direction, but its magnitude remains constant, because the only force is acting, that is the centripetal acceleration, the centripetal force towards the center of Earth. The torque developed due to this force will be 0 about the Earth. Hence, torque is 0, so no change in momentum, angular momentum. Hence, it says that it changes in direction. No change in angular momentum. Option B is incorrect. C, the total mechanical energy of S varies periodically with time. The total mechanical energy remains constant. It will not vary with time. This is incorrect. D, the linear momentum of S remains constant in magnitude. The linear momentum will not remain constant, as its direction, the velocity direction is changing, so linear momentum will not remain constant. D is also correct. So option A, we got the first option as the only correct option. This was the first I discussed. Rest I discussed why they are incorrect. Let's go ahead with the next question of the class. Next question we have 4. A double star system consists of 2 stars A and B. We have discussed double star system. Consists of 2 stars A and B which have time periods TA and TB, radius RA and RB, and mass MA and MB. They are given that they are having radius RA and RB and mass MA and MB. Choose the correct option. We have to actually relate, if you see the option, time period and radius. Now see, it's a case of double star system. Don't try to actually frame that TA equals to, it's proportional, T square is proportional to R cube. You will be reaching on there, and then again you will be finding some relation. Now see here, it's a double star system. In a double star system, time period is same for both the stars. So whether this A option you read, TA is greater than TB, then R is greater than RB. First of all, they both are same, so this option will be incorrect. B, if TA is greater than TB, then M is greater than MB. No comment, they will be same. TA by TB whole square is equal to RA by RB whole cube. They are same, and since radius is not equal, hence this is also incorrect. TA goes to TB, option number D, only right option. This is an, if you know the double star system, directly you will tick the option. Why this question has been asked? Because people don't do double star system concept question. And I have discussed this double star system in the regular class. I hope that you have taken note of that class and you have understood. So easily you can say that time period will be same for both the double stars that are actually rotating around the system, rotating around any planet or any sun. Now let's go ahead. 5th, imagine a light planet revolving around a very massive star. Light planet rotating about, revolving around a very massive star in a circular orbit of radius r with a period of revolution t. If the gravitational force of attraction between the planet and star is proportional to r to the power minus 5 by 2, then t square is proportional to r to the power 7 by 2. B, t square is proportional to r to the power 3 by 2. C, t square is proportional to r to the power 3 by 2. Actually, you just change here, it will be t square is proportional to minus 3 by 2. Both options cannot be the same, minus 3 by 2, 3 by 2. D, t square is proportional to r to the power 3.75. Let's go ahead, let's try to solve this question. First of all, it says that the gravitational force of attraction between the planet and the star is proportional to r to the power minus 5 by 2. The force of attraction provides the required centripetal force, that will be mv square by r, is proportional to r to the power minus 5 by 2. We can write v square is proportional to r to the power minus 5 by 2, and this r is going to multiply here. You will be having minus 3 by 2. This r is multiplied here, so you will be having minus 3 by 2. Now v will be proportional to r to the power minus 3 by 4. Till here I believe that it will be quite clear to you all. Now say time period we are talking about. If we talk about the time period is what? 2 pi r by v, right here. 2 pi r and V is proportional to, so what we can write? We can actually change its presentation. We can write T is proportional to 2 pi r and V is proportional to r to the power minus 3 by 4. So r to the power minus 3 by 4, we have obtained this. So T will be proportional to r to the power 1 plus 3 by 4, you will get that as 7 by 4, and then T square will be proportional to r to the power 7 by 2. So let's see here, the option number 1, A option, T square is proportional to r to the power 7 by 2, that is the right option for this question. So let me go ahead, and before that, what you do, take note of this entire solution, and let me start at the other end of the board. Take note of this entire solution. So I believe that you would have taken note of the entire solution, you would have understood how to solve such kind of question. Next thing, let's proceed with the next one. The next question of the class we have question number 6. Now here we have more than one option correct. Either one can be correct, or all 4, or 2, or 3. Two objects of masses m and 4m are at rest at an infinite separation. They move towards each other under mutual gravitational attraction. If capital G is the universal gravitational constant, then at separation r, A, the total energy of the two objects is 0, B, their relative velocity of approach is 10 gm by r power 1 by 2 in magnitude, C, the total kinetic energy of the object is 4 gm square by r, and D, the net angular momentum of both the particle is 0 about any point. So we got this. Now 4 options we need to check. First of all, two particles m and m, they are approaching towards each other. Initially they were separated with a separation that is infinity. You see here, are at rest at an infinite separation, both are at rest, m and 4m. So let me mark here, this is 4m, not m. Now you see here, as they come and the separation between both of them is reduced to r, that means there will be some potential energy. Initial potential energy is 0. Initial potential energy is 0. Final potential energy will be equal to minus g 4m into m by r. This is what we know. Minus g 4m into m by r. Now you see here, as they come, since they are coming due to their own gravitational force of attraction, there is no external force acting, there will be no change in total mechanical energy. They were at rest initially, potential energy was 0. So initial total energy, total mechanical energy initial is equal to 0. That will remain conserved, and even at this separation also total mechanical energy will be 0. For first option, the total energy of the two objects is 0. Yes, it is 0. Let's check the second option. The relative velocity of approach is this much in magnitude. Now see, decrease in potential energy, there is a decrease in potential energy, so that means there should increase in kinetic energy. So I am writing here, decrease in potential energy, this should be equal to increase in kinetic energy. This should be equal to increase in kinetic energy. Now how we can write the decrease in potential energy? That is quite obvious. That will be G into 4m into m divided by r is equal to half. Now which mass to use? That is the reduced mass. So I am using mu into relative velocity whole square. Half mu Vr whole square. I have used the term mu. Mu is the reduced mass and Vr is the relative velocity. Mu is reduced mass. The value of mu is, it is the product of masses divided by sum of masses. It will be 4m into m divided by 4m plus m. You should know this formula. This will come out to be m and m will be cancelled out. You will be getting 4m by 5. So we got this term. Now you see here, we need to find out with what velocity it is approaching. The relative velocity of approach is this much. For here, you substitute mu here in this way. Let's try to find out the value of Vr. If we substitute, and let me do the remaining part here. We do not need this, so I'm remaining part I'm doing here. 4g m square divided by r is equal to 1 by 2, value of mu is 4m by 5 multiplied with VR whole square. This is how you have to approach. From here you can see that 4 and 4 will be cancelled out, and then you will be having G, that will be there, then 5 into 2, 10, so VR whole square comes out to be 10 G m, 1m will be cancelled out, divided by R. VR is equal to under root 10 G m by R. So option B is also correct. The relative velocity of approach is 10 gm by r power 1 by 2. Yes, that's true. See, the total kinetic energy of the object is 4 gm square by r. For total kinetic energy, we can use 1 by 2 mu into Vr whole square. This will be giving you total kinetic energy. This will be equal to this. So 4 gm square by r. Let's check. 4 gm square by r. Yes, total kinetic energy of the object will be this much. That's true. D, net angular momentum of both the particle is 0 about any point. Since again they are coming due to only their force of attraction. Now torque about any point will be 0 due to this force of attraction. Since torque is 0, so we will be finding net angular momentum of both the particle is 0 about any point. Yes, even net angular momentum will also remain 0. No torque, no change in angular momentum, initial angular momentum is 0, so final angular momentum will be also 0. So net angular momentum of both the particles is 0 about any point. Yes, that's true. So all the 4 options are true. So I'll be writing here A, B, C, D. All options are correct in this question. I hope that you have understood and also practice this question after the session also. This would be very good for you all in your preparation if you also practice question on your own. Let's go ahead with the next one. At the surface of Earth, potential energy of a particle is U and potential is V. Change in potential energy at a height and potential at height h equal to r are suppose delta U and delta V. Then delta U goes to minus U by 2, delta U goes to U by 2, delta V goes to V by 2, delta V goes to minus V by 2. Let's check. First of all, it's given on the surface, the potential energy is given as U. We know that U equals to minus Gmm by radius of Earth. On the surface I am talking about. At surface, the value of potential energy is this and value of potential is minus Gm by r. We know this, quite obvious, that's quite true. At the surface of Earth, potential energy of a particle is U, so we have written that. Change in potential energy and potential at height h equal to r. Change in potential energy. Now at height h is equal to r, the final potential energy will turn out to be minus G mm by r plus r, so 2r you have to do. So you will be obtaining, this is how much? You can see that this is equal to U by 2. This is equal to U by 2. If you find the change UF minus U, if you do UF minus U, you will be getting, or U final, this is U initial, that is given as U. U final minus U initial, U by 2 minus U, that will come out to be minus U by 2. So the change in potential is minus U by 2, option number A matches, delta U equals to minus U by 2. For potential in the same way, can you think that potential is also negative in the same way, delta V will be also equal to minus V by 2 in the same way. So I will be just, because it's, if I show you stepwise, that will be just taking extra time. So delta V equals to minus V by 2, directly you can reach on to this result. So the rest you can see that option number D also matches. Two options that are true for this question, that is A and D are the correct answers for this question. Let's go with the next question. We have after this the next question of the class 8th. Integer type, so only one integer will be the answer for this one. The diameters of two planets are in the ratio 4:1 and their mean densities are in the ratio 1:2. Find the ratio of acceleration due to gravity on their surface. Acceleration due to gravity we need to talk about. It's given that the diameter in the ratio 4:1, so radius will be also in the ratio 4:1. Given that their mean densities are the ratio 1:2. So we can write both these terms as per given information. Next thing, it says that extended to gravity we need to talk about, that is gm by r square. We know this, gm by r square. Mass will be different. Let's write it in terms of mean density. So that will be equal to g volume multiplied with density. This is what we will be obtaining. So the final answer will come out to be, you see, r square r will be there. So you'll be having 4/3 g pi and r rho. These all terms are constant. Only r and rho is actually deciding the extended to gravity. So we have to compare, find the ratio of extended to gravity on their surface. So g1 by g2 will be equal to r rho divided by r1 r2 r1 into rho 1 divided by r2 into rho 2. r1 by r2, that was given 4/1, and rho 1 by rho 2, that was given as 1/2. So I'll be writing this as 1/2. The answer comes out to be 2. So g1 by g2 is 2. So you have to mark the circle that is containing 2. So the correct answer for this one will be integer 2. So this is how you have to do such questions, and this is how you have to mark the answers. Let's go ahead with the next question of the class. Question number 9. Two particles of equal masses m go around a circle of radius capital R under the action of their mutual gravitational attraction. The speed of each particle is v equals to under root gm by nr. Find the value of n. Now see here, two particles are moving around a circle. Two particles are moving around a circle under their mutual force of attraction. This is what is happening. Now see here, this is the radius r of the circle. So the distance between the two will be 2r. So if I talk about the centripetal force exerted on the second one by the first one, that will be equal to gm square, m into m gm square divided by 2r whole square is equal to mv square by r. So let me use here mv square, the radius will be capital R. We have to find out the value of the velocity, how it is related. So v, we have to make a relation. See here, first of all, let's cancel out this 1m, and then we'll be obtaining, now see, this is actually mv square by r. So we have obtained v square is equal to gm. You take this r here, you'll be left with gm by 4r. gm by 4r, and then v will come out to be under root gm by 4r. This is the result. Under gm by 4r, if you compare, n will be equal to 4. So let me write here, n will be equal to 4 for this question. This is the response, this is the answer for this question, n equals to 4. JEE asks such kind of question where you have to find the value of the some unknown variable, and that will be an integer as per the question. 10th one, assertion reason. You'll be provided with one assertion, one reason statement. Now it's given A, B, C, D. If assertion and reason both are true and reason is the correct explanation of assertion, then choose option A. B, if assertion and reason are true but reason is not the correct explanation, so choose option B. C, if assertion is true, reason is false. D, if assertion is false and reason is true. I hope that you must be knowing these 4 statements, how to choose A, B, C, D. Let's read this assertion. If a particle is projected from ground with some velocity, not very large, at an angle with horizontal, path of the particle is assumed parabolic, although it is not exactly parabolic. Let's read the reason. Magnitude of acceleration due to gravity at all places is assumed to be constant, although it is not so. That's true. We actually assume that acceleration due to gravity is remaining constant while it's during its motion, but that may change as per the vertical, the height, that may change. So yes, first of all, this statement is true, and if acceleration due to gravity is not constant, the path will not be parabolic. It will be somewhat something else. So what you see, if you see here, with horizontal path of particle is assumed parabolic, although it is not exactly parabolic. Yeah, that's true. So both are true, and this is the correct explanation of assertion. So choose option A. Both are true, and this is the correct explanation. So option A will be the right answer for this question. I believe that this 10 question would certainly help you for your preparation. Practice more questions for your examination. I wish you all the very best. I'll meet you all with more questions in the next class. Thank you, everyone.